Now here's the second question. We use the same region S as before, bounded by y equals to the square root of x, x equals to 4, and y equals to 0. But before in question 1, I rotated around the x-axis. This time we rotated around the y-axis. We rotate like that. Okay. Now can you imagine what volume you would get? What kind of shape you would get? Can you imagine?
Like a pinch cone.
A donut?
Okay, donut, pinch cone. All right. So it's like outside it looks like a cylinder, but you have this, right? Goes in. Right? This side is empty. Right? So that's the volume that we want to find. We use the same argument. Every volume is sum of its parts. So we use the same thing. Guess which way we should divide? Like that, right?
So across the x-axis? Across the x-axis or y-axis?
Yeah. So perpendicular to the y-axis. If we do that, then the cross sections will look like what? Like that, right? What is that called? Washers. Okay. We also know that this should be thickened in which direction? The y direction, dy. It's this direction, so it's dy. But if I say small r is the radius of the small circle inside and big R is the radius of the big circle outside, the area will be the difference between the two circles, right? So we have pi r squared, the area of the big circle, minus pi small r squared, the area of the small circle. That gives you the washer, and we're thickening it by dy. Okay, so that's what we have to compute. We have to compute pi capital R squared minus pi small r squared dy. And y goes from 0 to where? Not 4. Y goes from where to where? When you plug in 4 here, what do you get? 2. So what is this coordinate? 4, 2. So y goes from where to where? 2. 0, 2. Okay, so we have to calculate that, but in order to calculate that, we better have the capital R and small r as functions of y, right? Because it has dy. Right? I think the easier one is capital R. What's capital R? Can anyone just look at the picture and decide? If you understand, yes?
Wouldn't it be radical x minus?
No, it's not.
Minus 0?
No. Think about the picture before you say it.
Big R?
Yeah, big R.
Just be 4.
It will just be 4. Why?
Because that's the...
In this picture, big R is this length, right? Does it change?
Oh, that's the line.
It doesn't change, right? The distance from this to here does not change. That's your big R. R is just 4. The small r, however, does change, right? Because small r is this distance right there. Okay. But because we want it as a function of y, let's do this. We're just going to assume that y is a. Okay. And I want to know the x coordinates of these. I know what this is. This one here is 0, a, right? So the x coordinate is 0. That's not hard. But I need to know what the x coordinate here is if the y coordinate is 8. Because the difference between the x coordinates will be this distance, right? Okay. So how do you get this x coordinate? I know what this graph is, right? This is y equals the square root of x.
Did you plug it in?
Plug in what?
Well, X or Y.
A into Y, right? Yeah. So if A goes into Y, square both sides, you get X equals to A squared. So this is A squared comma A. Therefore, the difference between so RY is the difference between the x coordinates. X coordinate of this is 0, x coordinate of this is A squared, so you get A squared minus 0. Oh, but we wanted the function of Y, so what should we do? This doesn't look like the function of Y. What do we do?
Right in terms of
How?
Y squared?
It says Y squared. Why?
Because A.
Because A is Y, right? Yeah. It says Y squared. Okay, so that's your small r. Now we are almost there. It's now integration ready. 0 to 2. You can factor the pi out. And capital R is 4. And then small r is Y squared. So it's Y squared squared dy. Pull the pi outside the integral. 4 squared is 16. Y squared squared is y to the 4th dy. Integrating 16 by y gives you 16y. Integrating y to the 4th, you add 1 to the exponent, which gives you 5. Put the reciprocal in front, 1 over 5. And you plug in 2 and 0. And then if you plug this in and plug that in, that's 32. Eventually, you're going to get 128 over 5 pi. That part is just straightforward algebra, so let me skip that part. But the important part is being able to understand this. Is that good? All right. Now I talked about how you can do another kind of DV, right? Which is to use cylinders rather than washers. So think of a cylinder that's inside this thing. And as it goes in, it gets smaller because the height should be decreasing. And you can think of this entire volume as made of some of these cylinders that would eventually fill the entire object, right? If that's the case, let's think about how to write the integral. So here's our dV. Our dV is a cylinder, and you're thickening it so that it has some kind of a volume. Now, which way are you thickening it? It's a little harder to say because now it's like you're thickening this way, but also that way, also this way, or that way. And what's really happening is that you're thickening it in the radial direction. It should be like dr. But they'll be easier to think if you're in Calculus 3 and you've learned polar coordinate system, then what I'm saying should be easier to understand. But for us, let's just think of it like this way. We're just going to say this is our thickness, which is the x direction. Right? If you go this way, that's the x direction. Right? That's the y direction, this is x direction. So we're going to say that that's the thickness will be the x direction. But then the volume of this thing should be the thickness times the area of this cylinder. So we need to find out what this area is. Assuming that height is h and the radius is capital R. How do you find the area of such a thing? By the way, this cylinder is just the side of a cylinder. It's not. It doesn't have anything inside. Okay. It's just if you took a paper and rolled like that, that's what we want. Okay. All right. So if you have such a thing, how do you calculate the area? Any ideas?
Area of the circle twice, and then the rectangle that is the column of this.
Right. So if it was a surface area of a cylinder, then you would do area of 2 circles plus the side, which is a rectangle. But as I said, we don't have the top and bottom. We only need this side, And you're right, it's a rectangle. If we take a pair of scissors and then cut it through here and open it up, it's going to end up being like that, right? It will be a rectangle whose height is still h, same thing as here. What will be this length though?
Circumference.
Circumference, which is 2 pi r, right? 2 pi r. That's the circumference formula, 2 pi r. So the area would be 2 pi r h, base times height, with dx. So this is going to be 2 pi r h, and then you thicken it by dx. Let's try this one to see what the answer would be. By the way, 128 over 5 was our answer. Times pi was our answer. It should agree with the other one. Okay. Back to this picture. Our cylinders are like this. You have this as your height, and it goes like that. This is your radius r. And both should be changing as you change the value of x, right? Okay. So we want to add up 2 pi capital R h dx. Let's think about the formula for h and r. First, just say that x is equal to a. In that case, what is this height? Can somebody tell me? If x is a, what's the height? What's the equation for this one? Y equals the square root of x, right? What's the height if x is a?
Square root of a.
Square root of a. So that's the height. H is that. What is this length? From here to there.
A minus.
That's why we want to know. That's the r. But if you're at a comma 0, what is this length? A, yeah. It's just a. Same thing as a, right? Yeah. Okay. So what we know is that r must be a, and h must be square root of a. Oh, but wait. This is what we decide to call as x, right? X is a, so this must be x, and this must be square root of x. Okay, so now we can further rewrite this as 2 pi x times square root of x dx. And x goes from where to where? X varies from where to where? 0 to 4. It goes from 0 to 4. Let's bring out the 2 pi outside. And this is x to the first power. Square root of x is x to the 1/2 power. Therefore, x to what power? What's 1 plus 1/2?
3 over 2.
3 over 2 dx, and x goes from 0 to 4. Okay, next, you add 1 to the exponent. What do you get? x2,
5 over 2.
5 over 2.
2 over
Put the
5.
reciprocal as 2 over 5. And then you plug in 4 and 0. So we're almost there. This is 4 pi over 5, right? And then 4 is 2 squared. The reason I want it to be in this form is because if you have an exponent here and an exponent here, they multiply, right? So if you multiply, what's twice of 5 over 2?
5.
Just 5, right? So you end up with 4 pi over 5 times 2 to the 5th power, which is 32. And 32 times 4 is indeed 128 over 5 pi. Same as our previous answer. Okay. So this is a quite general formula. If you feel like this doesn't say anything, but this says a lot, it just requires you to specify what dV means. And depending on the way you split it, you get different calculations. What's significant is that here both intervals were okay to compute. You'll find later that there are examples where it's impossible to do it in the washer method, but you can actually calculate in the cylindrical method and vice versa. So there are some calculations, depending on the way you chop it, you get different integrals, and some integrals are a lot easier to do than the others. Yes?
So would you get the same answers with both?
You always get, you should always get the same answer from both methods, okay? It's just that in some cases, one gives you the easier integral to do than the other one.